Well, hello, folks. I think we'll go ahead and get started. Um, just to be on the safe side with all of the rain, the last time I checked that there was still a flood warning that would be active until 4 o'clock today. And I actually heard that one of the dorms actually flooded. So I figured it would be better, and I got concurrence with my chair to go ahead and do this online today. So let me go ahead and open up in prayer, and I'll give you a sense of what we're going to be covering. And then I look forward to doing that with you. So, dear Heavenly Father, Lord, I pray that you would be working in the lives of each of the students in this course, Lord. I pray that the material will be clear. And as they get a chance to explore abstract data types, that they can have an enjoyable time of doing the coding. And this is going to be contributing to them getting the jobs that they would like in the future. Pray that you would help them in their spiritual formation, Lord, that all of the times that they get a chance to be studying scripture, the courses that they're taking, that they'll be getting a chance to getting a better understanding of the message of scripture and give them interesting insight and help them to know how to pull out the theological concepts and approaches of how they can be applying that to the life. And finally, Lord, I pray that you'll give them interesting and creative ways for faith integration in their future. In Jesus' precious name we pray. Amen. Okay, well, today we're going to be transitioning into the next abstract data type. And so we're going to be talking about lists. And so it's interesting when we've been doing stuff in terms of our implementation. A lot of times we have been dealing with either arrays or linked chains and stuff like that, but this is the first time that we're going to actually have that exposed to the user. Um, and so that would be something that might be rewarding, and we're going to see that there's more methods that need to be implemented. And so this will be a chance to, first of all, let's get an introduction to that. And so remember, there's a couple different ways that we're doing programming. We're doing some back-end programming, and so that's where we're trying to do an implementation of an abstract data type using an interface that's been defined in class. And then we get a chance to be doing an application program, thinking like a user how would be using different capability. And so we're doing a little bit of back-end, front-end programming with what we're trying to accomplish in this course. And it's a level of type of capability that maybe this may be the first time where you've started to have a chance to do that while you're here at APU. So as is typical, and it's nice in this situation, we'll actually have 3 chapters to go over lists. We'll get a chance to introduce the concept, and then we'll have a whole chapter dedicated to implementation where we're using an array, and a separate chapter looking at the implementation where we're looking at a linked chain approach to that. We'll also then start to get a chance to be seeing what it's like to be using the ADT list. And so those are a couple different slides that will be handling that. And just to give a comparison, we will be looking at the Java library. Now, this is not the interface we're using. It's not the the way that we're going to be doing a list, but we'll get just a brief introduction to that to give you some comparison. So I think each of you have had experiences with lists. It's something that we use on a regular basis, whether it's a to-do list, things you want to get done today or something like that. You can be thinking like this, trying to focus on what's necessary for each of your classes. You can be having a gift list. I think one of you is doing that with having a wedding registry kind of application, or a grocery list, trying to think about what specifically that you need. Items in the list have a position. So this is something new. This is the first time where we can have that ordering, and we don't have to like take them all off the stack or take them all out of the queue to reordering that. And we'll have a chance to be thinking about sorted lists, not right now, but that's something that will be coming a little bit later. And so the position may or may not be important. And so that would be one of the things we want to be considering is how we're going to be using it for our application. And items may be added anywhere. And that is something that is interesting and useful for what we're trying to think about here. So this is a specification for the ADT list that we're going to be using in this class. And this is not the same as what is in the Java built-in list. There's actually more capability here. And when we were looking at the stack and looking at the queue, when we looked at the Java built-in, there actually was more capability, but now it's the other way around. And most notably, we can see that we can either add to wherever the data structure wants to add it, or we can add to a specific location. And so that's actually interesting, and we're going to see how that is useful. And so we can manually create a sorted list, even though that's not something that it does on its own. We can do remove, we can do clear, we can replace. So we can go to a specific location and replace the contents there. We can get an entry, we can put all things to an array. This is something we have with bag. We can do a Boolean to see if it contains something. We can get the length, and we can also query whether or not it is empty. So this chapter is just getting a chance to get exposed to this general capability. We're not going to be focusing on the implementation. So first we see how it performs when we're adding. And so if we add A, it adds it to the list. Add B, it puts it right after A. And then if we add C, it's going to be putting it after that. So this is what we have for those. Now we have this more surgical thing that we can be adding to a certain location. So to location 2, we're going to add D. So this is not in alphabetical order, it just happened to be up here. We can add E to the first location. So here we have that. Now D is not the second location, it's moved down. So everything in this list has to move down by one location. And finally, we can remove the third location, which was a D. So now we have that. So we can see a couple of the key methods in action here with this view. So here we have just a more detailed run through on the various methods and what they do. And so we start out with the two types of add, the general add. And so it lets the data structure decide. And so we saw how that was going to be working here. Or the other one was to add to a specific location. And so this is where we're the user, the application is giving that insight. We can remove a given location, clear, we can replace. Those are all possible things we can do. We can get the entry. So this is like when we did a peek. We can have it all going to an array. We saw that with bag. We can do a Boolean where we can see if it contains something. And then we have the get length and is empty. And so based on some of the tricks that we've seen with some of the options there, if we just hold the right variable, some of these things are going to be easy for us to determine the answer to that. So once again, this is the interface. This is not the one that's in the built-in. And so as is typical, we see a general description. What are the parameters that are going in and out of this list interface? So we have the two types of add, then we have the remove, we have the clear, replace, get entry, to array, and contains, and finally the get length and is empty. So I don't know if I'll get to it today, but we can be doing this on Thursday, depending if folks want to be spending more time going over stacks first, stacks and queues. Here is an example of a road race. Maybe some of you have run cross country or been in track, or you've watched some events like that. We're coming up to the Olympics, and so this would be something that we can get a chance to be seen about it. So it's roughly, you can see how this works. Number 16 crosses a finish line first, and so it's going to be the first one in this list. Number 4 is the second person to cross, 33 is a third, and 27 is the fourth person to cross. So this is say a good example of how we could be using a list, we could be doing this with a queue as well. And it sort of depends, like, what are the other features that we want to be taking advantage of that would have us want to be going with a list. So that's just something to be thinking about. So we're not talking about the implementation, we're thinking about this from an application point of view. And so we're assuming that we have an implementation that we can leverage. And we're have an A list is what it's called. So maybe that's an array. It not necessarily could just be stating that the name convention is just saying it's a list. So here we have our public static void main. And so we have all of that. And we then want to have a method record winners. And so we're fat fingering this, and so we just have 4 individuals that we have in this race. At least that's all that we're putting in. And so we have the winner, the second, third, and fourth place finishers. All of those are recorded. And we can see that. And so 16 is the first entry, 4 is the second, 33 is the third, 27 is the fourth. There's some more details here that we're not getting a chance to be seeing here. The list contains 4 entries. And so the number of entries, we're keeping that as a variable. So we're going to always be aware of what the length of what the list is. That's going to be helpful. And this is we go from position 1 to the end of the list. We're showing here that we can be showing that 16 is the first entry, 4 is the second, 33 is the third, 27 is the fourth, and voila, we have this. And so we don't have to leverage all of the methods in an application, but when we're doing our testing, we want to be able to do all that. So we can keep that in mind when we're thinking about what we're doing here. Well, let's have a couple of slides where we look at how we can be using the ADT list. Once again, we're not dealing with the implementation yet. And so here we're using the second method for add, where we're adding in a certain location. So we just add the first one to Amy, then we add Elias. And so these are in alphabetical order. And we put Bob into number 2. And we're manually doing this, but we're still maintaining this alphabetical order here by just having a smart way that we're doing those additions. We do it with Drew, and then finally with Aaron, we once again keep it alphabetical order, and see Carol, we put it in item number 4. And so this is something that this list itself cannot put in an alphabetical order, but that onus is put on the application that it has to be maintaining that way, that when you get a certain one, that you have to be thinking about what came where, and we can maintain that alphabetical order. So that's kind of an aside what's happening. So we can also have a list of a name objects rather than a string. And so here, we're just creating a naming convention where we have 2 names, Amy and Smith, say a first and a last name, and then we could just add Amy, and it's going to have that put at the beginning of this list. So this is the other form of add, and so it just adds wherever it's convenient for the data structure. So this will be the first one, this will be the second, this will be the third. And so then we have Tina Drezel and Robert Jones. All of those things are there. And then we can be have the second name be the name list of get entry number 2. And that would be Tina Dressel. So those are the possible things that we could be generating. Well, let's look quickly just at the interface list in the Java library. So you have 1, 2, 3, 4, 5, 6, 7, 8. And so this one, we only have one add, and this is for at a specific location. We don't have this add where it just defaults and it let the data structure decides on its own. So that's just an example of one of the differences. We don't have get length is empty. Those are things that are within our implementation. And so let's just pause and think about that for another minute. So we have this built in, but for our application, we need more capability. And so here we have, due to the nature of what we want to be accomplishing, we need to do more. And so that's where getting a chance to be familiar with how you create an interface. And so you're creating that separation between your back-end implementation, your front-end application development. It is something that you're going to be bumping into in the future. And there's also some other things that are available in the Java program itself. And so I'm not going to get into that, but those are just a couple other things um, on that. Okay, so I think that's it for. All right, well, I'm sorry about that. I'm not quite sure what happened. Um, so let me go ahead and start sharing my screen again. Hopefully it'll behave now. Um, so anyway, I hope everybody is doing well, in spite of the weather and keeping safe here. So we were getting a chance to get an introduction into lists. And so I went over the lecture material, and now what I wanted to do is, well, let's go ahead and follow along and see what our authors say about that topic here. And so hopefully my browser is going to behave here. So let's give this a go.
This lecture introduces the concept of the ADT list. But first, let's review the ADT bag. The bag is a collection of items that don't have any order.
So as we're progressing through this course, we're introducing new abstract data types, but we also want to be mindful of what we covered in the past. And so it's like having a toolbox of if I'm going to be using a hammer or a screwdriver, it really depends on the application. And so now we're going to see that there are some similar things between a list and a bag. And so that's why we're going back here for a moment. But for a bag, there's no order to the items. Well, we're going to have something different for a list.
Items are simply in the bag or they're not in the bag. A list provides a way to organize data. We can have to-do lists, gift lists, address lists, grocery lists.
So say for a grocery list, it doesn't need to be in alphabetical order. Maybe like I know when I go to Home Depot or something like that, if I go online and figure out where items are in the store, it'll tell me what aisle, even what bin. And so that's something I found out about a year or so ago. But for whatever, usually like all of the produce is in one area, you could find that. The meat would be in a different area. So you could finally figure out how to navigate this, or you just check things off one at a time. But anyway, there is a position for the items on the list. Now, if it's an electronic list, you could reorder it. If it's on a piece of paper, you're not going to have that ability to do that. So that's also gets into some implementation details.
Even lists of lists. These lists provide a useful way for us to organize our lives. Each list has a first item, a last item, and usually items in between. That is, the items in a list have a position, first, second, and so on. An item's position may be important to you, or it may not be. When adding an item to your list, you might always add it to the end, or you might insert it between two other items already in the list. When you work with a list, you determine where an entry should be. You probably are not conscious of its exact position. Is it 10th or is it 14th? However, when your program uses a list, a convenient way to identify a particular entry is by the entry's position within the list.
So, as is typical when we do an introduction to an ADT, it talks about the capability in a narrative form, and then it'll gradually start to put it into how we're going to actually code this. And so having a first position and a last position, that can be helpful. Having the number of entries, that's going to be helpful. So we're just seeing some of that unfold here.
It could be first, that is at position 1, or second, position 2, and so on. This convention allows you to describe or specify the operations on a list more precisely. Everyday lists, such as to-do lists, gift lists, address lists, and grocery lists, have entries that are usually strings, and so we'll use that as our example. What can you do with such lists? Typically, we add a new item at the end of the list. For example,
this is going to come up as we get into the second half of our class here. we have this numbering convention, like you typically, when you create a list, you start with item 1 rather than 0. But if you have an array, you start with the first item is 0. So just keep that in mind. There's going to be a numbering convention that we may have to go back and forth with.
When making our grocery list, we might simply write down items as they come to mind: apples, oranges, cheese, and tomatoes. Actually, we can add a new item anywhere, at the beginning, the end, or in between items. We might want to place bread first at the first position so that we don't forget it and move each of the other items down one position.
And once again, like I used an analogy, if we know the layout of a store, maybe the bread items are close to the entry. That's what we have with a grocery store close to us. If you go in one door, we have the bakery there. All of the produce are on the other side of the store.
We may want to add nachos to the list next to the cheese, since we may want to buy these together.
So here's another perspective, and maybe you're trying to think in terms of menus and you wanted to have those things together. Maybe it turns out the nachos would be close to where the cheese is.
You can cross out an item, that is, remove it. For example, if we remember that we have oranges at home and don't need to buy them anymore. After removing an item, each of the items in the list move up a position. We can
You're going to see that can be difficult in terms of the implementation. That could cause if you have to move everything up. That can be one of the liabilities that can be associated with lists that you need to figure out, is that important enough to me to maintain that order?
replace an item in the list, so that if we decide we want to purchase low-fat cheese for our nachos, we can make that change. Some of the other actions we can take with our list are looking at an item, looking at all the items, finding out whether the list contains a particular item, counting the number of items in the list, checking whether the list is empty, and removing all the items or clearing the list. To specify the ADT list interface, we describe its data and specify the operations on that data. The ADT list interface is general and has entries that are objects of the same type, T. The following is an initial specification of the ADT list. The ADT list is a position-oriented data structure. That means that we can access entries based on their location in the list.
So it's a position-oriented data structure. That's what we're going to implement, what we're going to create when we call upon this abstract data type. So thus, for our application, we want that to be something that's important to us. And so we're going to want to take advantage of that.
Just like your shopping list, our positions begin at 1. I mean, how often does your shopping list have an item in position 0? So the entries in a list of n entries are numbered from 1 to n. Although you cannot add a new entry at position 0, you can add one at position 1 or at position n plus 1 or anywhere in between. You can only remove items from positions that have entries. Therefore, you can only remove entries at positions from 1 to n.
So we can think about this for a minute. So I showed you that illustration of a road race, and I'll try and pull it back up here in a minute. But so what do I want to be evaluating for that road race? And so now with your overall project development that you're doing, this is something that you could start to be thinking about. Do I just need that one, who came in first, who came in second? Is that what's important? Or do I need something in addition to that? And the answer is, since you guys are trying to do a lot of different things, you're starting to get a chance to get familiar with a bag, with a stack, with a queue, now with a list. You're going to see some of those differences across one another and say, okay, now I got a better sense that like stack gives a nice little history perspective. A queue is focusing on who comes first. And so maybe if I'm doing a road race and that's all I'm trying to do is who came first, maybe you could model it with a queue. And so that would be an example of something that you might want to be thinking about in terms of what's the best implementation for your application. Okay, well, let's go to the next video. Gets into the using, and maybe some of those thought-provoking questions that I mentioned might be things that we'll get a chance to explore a little bit more here and have a dialogue.
This lecture presents an example of using the ADT list. Here's the list interface we developed in our previous lecture. Let's remove the comments to save some screen space so that we can keep it handy during our examples.
So remember, what we're using for our ADT, abstract data type list, that we were using in this course, it actually has more methods than what is contained in the default one that's built into Java. We have two adds, for example. We have contains, clear. So there are a couple more capabilities that we decided based on the feedback that we've gotten from those that are using our capability. So users, that's what we could argue is why we're doing it this way.
In this example, we'll first create our grocery list. It'll be a list of strings. We'll add apples, oranges, cheese.
So what we are showing in the lecture notes, we are showing a road race. Now we're talking about a grocery list application. So different things, different types of lists. And so for your part, what you're going to be doing in your project, do you envision that what you're creating, it looks more like a road race or a grocery list?
And we're just calling the class's add method. So each of these are being added to the end of the current list. And then we add tomatoes. We can add at position 1 bread.
So you might remember in the last video note, it did this. It had various groceries, and it says, oh, by the way, I want to have bread be the first item. So that's going to come up here, and that means that each one of these ones have to be moved down a location. And so that's going to be some overhead in the implementation that you're going to have to manage.
Inserts bread at first location, and then all the others move down one position. If we add at position 4 nachos, cheese and tomatoes, which were after position 4, are moved down, and nachos are inserted at position 4.
So once again, we're focusing on the front end programming here. We're not talking about the implementation of how we make this happen. And so here we came up with this idea that, well, maybe we wanted to have the nachos with the cheese. And so this is something that the user is deciding where they're going to put things in the list.
We can remove oranges at position 2. And notice we specify the position when we do our removals.
Yeah, so once again, it's the position. We didn't say remove oranges. So that would be a different kind of thing. We'd have to find out where it is, and then we'd have to do the remove.
Also, we can replace at position 4 cheese with low-fat cheese. And we specify the position and then the new value for the entry at that position. We can call the method getLength that returns how many items are in our list. In this case, it'll return 5. And then we can print out the list contains 5 entries. And then use a simple for loop to get each entry by specifying the position and have that printed out on our display.
Okay, so that's a good introduction to what the ADT list is. And what we can do is go through the implementation a little bit. But before I do that, let me see if there's any comments or questions on this. You guys following what we have here? Okay, good. So really in at a conceptual level, for the most part, these things are fairly easy to follow. It gets more complicated when we start to be talking about the implementation. You've already seen some of the things that are helpful. We talked about a circular array using the module operator and that helps to give better reuse of an array. We even saw a module operator that was used for a linked implementation. So that's one of the things so far that's started to come out. And then we've started to see some of the coding approaches that the authors of our textbook tend to favor, and to see what we think about it and incorporate that into our style of programming. Okay, well, in terms of what's in the textbook and what we'll start to be thinking about here, we'll think about using an array to implement the ADT list. We'll give an analogy, and we'll also be thinking about the Java implementation that it does, although that's not what we're going to be doing with our particular coding. And then we'll start to think of the efficiency of using an array to implement the ADT list. Ultimately, saying if you have a huge data set, that's going to make a big impact. We've already had a chance to get introduced to the big O notation and how that can start to make a difference. So we can be thinking about a classroom that contains a fixed number of desks or fixed positions. And so that's what we have with an array. We start with the first one here. And so we go from 0 to 7, 8 to 15, and so forth to finish up the whole room. So now we want to be thinking in terms of that situation as like, well, where are we going to put Doug? And so are we going to put Doug between Carol and Ed? And so Ed's going to have to move his seat. And so one way to be thinking about it is we're trying to keep in an alphabetical order. Maybe that's the way that the teacher wants to be organizing students in the course. So hypothetical, but we can be thinking about that. So this is looking at the ADT list in UML notation, but this is a little bit more than that because now we're talking about the array implementation. And so we have these couple things that show up, and you might remember these already. The default capacity, the max capacity. We have this Boolean integrity check to make sure that our arrays are still working properly. All of those things are laid out, and we actually have our list that we have to actually create an array that's used in our implementation. Then we have this way of trying to annotate whether or not something comes back. And so if there isn't, then we put void here. Otherwise, we have our generic type T. Say if we're doing a remove, we're going to report back the thing that we removed because we just passed it the integer. And so those are just a couple examples that we see here for looking at the details of a list. This gets into the implementation. And so this is the standard way that we do it for an array. And so we have things that we just saw here with the UML. This is now just laying that out. And we also give specific values. We have a default capacity of 25, max capacity of 10,000. And so the first thing we have is the first of two constructors, the default constructor. And so you just do a list and you don't specify how large it is. And so what it does then, it then launches the other default constructor with a default capacity of 25. I'm not sure if this one will show that. Yeah, so this is the more detailed version of the constructor. And so we've already gone through this already. You start with the integrity okay equals to false, and then you go through these lines to verify that things are fine. Here we were trying to check to see if the initial capacity is too small, and that would be one thing, and also if it exceeds the maximum capacity. Those are all things that we're going to be checking. And then we actually create the new list. And so we just make it as a general object. And then finally associated with what we're going to be doing here. And so voila, that's our two constructors. The first was the default with no setting the capacity, and the other one is where we set an initial capacity. Then we get into the specifics in terms of the methods. And so the first one is we have add with no entry. And so we look at the implementation, it's going to just put it at the end of the list. We saw this in the last chapter when we were just looking at this notionally. And so here we have multiple steps. We could have also have done this a little bit more compact. And so this is going to be up to you if you found that that was helpful for you. So either way would end up working. Then we just defer. We're not going to be showing these other methods in detail. This is, we'll come back to that in a little while. So we have the two array, and so I believe the last time we hit this was with a bag. And so now we have a way of, we can get the whole internal, what's done in the back end, the array, sent out to a list, an array that can actually be sent to the user. And this is the code for doing that. We do some integrity checks to start out with. We have the manipulation of what we're going to be doing with okay, so we create the array that we're going to be putting the values to, so we don't copy our gold standard that's kept in the back end of the implementation. We create a new array, and then one at a time, we put those values into the array. And when we're done, we have this is completed, and so we return the array, and so voila, we have that. Then we have the contains, get length, get number of entries. These, okay, we have the contains, and so this is deferred. We have the get length, and since we're keeping this variable, the number of entries in the beginning of our code, this makes it very simple for doing an implementation of that method. We just have to do return the number of entries. One line piece of code for implementing that method. That makes it pretty easy. So we have the length, one line of code. I think there's a duplication of this method up here. And then we have the is empty. And so then it's just a Boolean check, is the number of entries exactly 0? And then it returns that. So it gives a Boolean either true or false. We have our private methods, and the way that they do their coding is they typically put the private methods at the bottom. We don't have any private classes with an array in this situation. So we have that. And here we can see how things are going to happen. So we have an array with 4 elements. We want to be putting in a space so we can be putting in Carla. And so these are the steps that we have to go through. We have to move Haley, we have to move Doug, and we have space to put Carla. And so those are the overhead items that would have to occur when we have an array for this kind of implementation. Here we have the implementation for including an element at a specific location. We do the check integrity. And then we have a Boolean check. If the new position is greater than 1 and the new position is less than the number of entries, okay, we're fine. We can do that. And so then we have another check to make sure that the new position is less than the number of entries. And if that's the case, then we have to make room Otherwise, we don't need to be doing that, and we can just go ahead and add the new entry, increment the number of entries, and return. And if it turns out that this initial condition was not met, then we're going to be throwing an exception to the given position of adds new entry is out of bounds. So that's going to be a nice clean way that the user of the code is going to be able to follow. And so now we want to be doing a remove. We want to remove Bob. We take that out, and we're going to have to move one at a time all of these elements. So instead of having 5 entries, we're going to have 4. So that is the notional way of how this would look. And then we can have the code implementation where we can look at it here. So we do our check integrity. We have, like similar to what we did with the add, we do our Boolean checks to make sure that it's the given position is greater than or equal to 1 and less than or equal to the number of entries. Here we have, we're checking to see, we'll have the result of generic type T is the list of the given positions. So this is the item to be removed, and this is the one we want to be sending when we return. So this is how we're loading that up. If the given position is less than the number of entries, we need to remove gap. And this is a situation here where we had to manually go ahead and do that. Then we put the number of entries. So we're taking one out, and so we're setting as null the entry that was here before. And so before there were 5. And so this last entry is going to be turned into a null. We decrement the number of entries and we return the result. And the result is what we defined up here. And if this initial assertion, like we showed before, comes up with a false, then we throw an exception, a legal position given to remove operation. And thus we got that complete. Okay, this is the private method for removing the gap. And so here we pass the given position. It's going to have access to the array, and it's going to, one at a time, remove that gap and move everything over one position. And so that's what we have for that private method, remove gap. Here we have the contains. And so basically we're going to be checking, and you're either going to return a true or false as to whether it found it. And so we use a while statement while it has not been found. And so if there was 2 entries, it doesn't matter. We have to just find the existence of at least one. And so as long as this still remains false and the index is less than or equal to the number of entries, we continue one at a time using a built-in comparison to see if this entry is equal to the value that we're pointing to in our list. And then if it is, then we convert the found to true. We increment the index, and we do this until we finally get to a point where there's a true scenario, and this knocks it out and returns the found. Okay. We have the add entry, and so we do our check integrity, just a good method for doing this. We add the item at the end of the array, we increment the number of entries, and then we do an ensure capacity before we go ahead and return. Those are the items for doing that. Then we have using an array to implement the ADT list. We have the add to a given position. So here we adding a new entry to a client's specified position. And so we have, just as long as the given position is greater than or equal to 1, and the given position is less than the number of entries, and we're going to go ahead and proceed. If the given position is less than the number of entries, then we invoke the make room. So we have to put it at, make room for it to fit into that position. Then we have at that position, we do put in the new entry, and then we increment the total number of entries. And then we go back to this outer loop. And so if it turns out that we're out of position, then it's going to give this error message of given position of add entry is out of bounds. And finally, the last method that we have, this is showing the implementation for the make room. We have the new entry is at the given position in the last index. And so we go from the increment that one at a time to move things over to make room to give this kind of a scenario where we're trying to make room for Carla. Okay, well, I think that's a good breaking point for today, but let me pause and see if there's any comments or questions before we end our lecture. Thumbs up if you're tracking this. Okay, good. And I can ask again on Thursday, but if you have a sense, do you want to be having us go over some more Q examples or start to show some list examples on Thursday? So either you can just put that in the chat if you want, if you've already have an opinion, or you can just tell me what you think. Okay, well, I'll just defer to Thursday. Let me know. And and if I don't hear an answer, then I'll go use my best judgment of what I think would be good to keep us progressing and helping us understand how we're doing this all. Okay. All right. Well, God bless you. Sorry about the snafu on my computer, but we'll see you all on Thursday.
Thank you.
Okay, Professor, see you Thursday.